Today, you guys will be learning lesson 9.2 on graphing quadratic functions with a middle term. Okay, these are different from the ones in 9.1 because 9.1 was y equals ax squared plus c, where the axis of symmetry was always your y-axis. Okay, these ones that have the middle term, so they look like y equals ax squared plus bx plus c. Okay, they have that bx term in the middle. These ones don't have an axis of symmetry as y equals as the y-axis. Okay, you have to find it in order to figure out where this parabola is reflected at. Okay, so in order to find it, there's a formula you get to use. Okay, the axis of symmetry is found by x equals negative b over 2a. So we're looking at these first two coefficients. Okay, here's my a, and here is my b. And whatever that sign is, remember that goes with your b term. Okay, what that is, since it's the axis of symmetry, okay, is also the x-coordinate of your vertex. Okay, and if I know one of the values of either x or y, I can find the other one. Okay, that's why that formula is so important. Okay. The c is our y-intercept, okay? So this always tells us 1 point on the graph, and the reason it's your y-intercept is if you plug in 0 for x, remember that a times x, no matter what, if x is 0, goes away, and that bx, no matter what b is with a 0, goes away, okay? So to graph a quadratic function that has that bx term in the middle, your first step is to find the axis of symmetry using the formula x equals negative b over 2a. And we draw that in using a faint dashed line, okay? So we're going to just put dashes down so we can see where that parabola is reflected around, okay? Then I know the x value for that vertex because that vertex is always on your axis of symmetry. So I can find the y value by plugging that x into our original equation. Then I just have to solve for y, just like we did when we made the tables, but now we're not doing it in a table. Okay. Then I'm going to plot my c, which is my y-intercept, and I'm going to reflect it over the axis of symmetry. So if I have that axis of symmetry, and sorry, I'll make that dashed, okay? This is my axis of symmetry, and my c is over here, and that's 2 hops away, okay? Remember, it's reflected on the other side, so across from that, we also have a point 2 dots away, okay? And so since we need to have those 5 dots to graph, what I do is I find another x to sub into my equation and solve. Okay, the easiest one to do is going to be this x value. If you look at my drawing I was drawing here, that's in between the axis of symmetry and your y-intercept. Okay, because then we know what's going to be on our graph. Whereas we pick one that's outside of those, and sometimes you're going to have to, but sometimes those get to be really big numbers and they aren't on your graph. Okay, or else you have to make your graph a lot bigger. So if you can, pick the point inside those. All right? So try one of these. Okay, so my first step is going to be to identify my A, my B, and my C. Okay, so if I look right here in my equation, this is A, okay, this here is B, and here is C. Okay, so for this problem, my A term is -1. Stylus is not cooperating with me today. Okay, my B term is a +4, so we can just write down 4, and my C term is -2. Okay, so then what I'm going to do is I'm going to find my axis of symmetry, and I'm going to abbreviate that just because I have a small screen, but I'm going to zoom in here a little bit. Okay, so I'm going to look for my axis of symmetry. I'm just going to call it okay, of S. Okay, and remember that's the formula, negative b over 2a. Okay, so I'm going to plug in my numbers. B is 4, so I have negative 4 over 2 times a, which is negative 1, which gets me negative 4 over negative 2, which gets me my axis of symmetry at 2. Okay, so on my graph, I'm going to draw that dashed line, okay, at 2. Okay. Okay, now this isn't any points on my graph yet. That just tells me how my parabola is reflected. Okay, so once I know that, I also know the x-coordinate of my vertex. So the next thing I'm going to find is my vertex. Okay, remember that's either the minimum or the maximum on your graph. So we know the x-coordinate of that is at 2. Okay, so to find y, I'm going to plug that into our original equation. Okay, so what I have is y equals negative 2 squared, and notice that negative is outside of those parentheses, okay, plus 4 times 2 minus 2. I'm just taking that x value and plugging it into the equation just like if I was working with a table. Okay, so what I have here, negative's outside of it, so it stays negative. Okay, so I have a negative 4 plus 8 minus 2. Okay, and if I combine all those, negative 4 plus 8 is 4 minus 2, which is 2. Okay, which gives me the y-coordinate for my vertex. So for this graph, my vertex is at 2, 2. So I'm going to put a point at 2, 2. Okay. And by looking at this equation, okay, it's still true that if my a term is negative, we should know that this is going to be the maximum value for my graph. My parabola is going to be opening upside down. Okay, so the next point I'm going to graph is going to be my c term, which is my y-intercept. Pen is really not liking me right now. Okay, which is c equals negative 2. Okay, so on my graph, I'm going to put a dot on my y-axis at negative 2. Okay, and since again I'm making a parabola, I know it's symmetrical. So to find the other point, I'm going to count how many boxes I have to get to my axis of symmetry. Okay, so I'm going to start at that y-intercept, and then to get to my axis of symmetry, I go over 1, 2 dots. And if I do that for the left side of my parabola, I also need to do that on the right side of my parabola, getting me another dot right here. Okay, and so the last step is to find that other point to plot. Okay, we always want to have 5 dots on our parabolas. Okay, because then we have a better representation of what it looks like. Okay, in this one, like I said, you can pick any x value you want to. Okay, I could pick negative 4. Okay, but that's going to be way over here somewhere. Okay, and it's going to be off my graph. So I don't want to pick that one. Okay, so I'm going to choose this point right here. Okay, I don't really want to put a dark mark there, but I'm going to pick this x-coordinate right here because it's in between the known points. Okay, it's in between that y-intercept and my axis of symmetry. So I'm going to solve for when x equals 1. And I'm just going to again plug that into my equation. So I have y equals negative 1 squared plus 4 times 1 minus 2. which gives me -1, because 1 times 1 is 1, plus 4 minus 2. And when I solve that, I get 3 minus 2, which is 1. Okay, so I have a point at 1, 1. So my graph, 1, 1 is right here. And to find my fifth dot then, I just again reflect that to my axis of symmetry. So that's 1 box away, and 1 box over then on the right gives me my other point. And I'm ready to draw my parabola. And remember, when you do that, it should be a smooth curve going through those dots. Okay, through that vertex. We don't want it to be a point. All right, let's try another one. Okay. So first step is again to identify your A, B, and C. Okay, so for this graph, my A is 2. My B is also 2. And my C is 1. Okay, so my first step is to find that axis of symmetry. Again, I'm going to abbreviate that, is A of S, okay, which is -b over 2a, okay, b term, so I have -2 over 2 times 2, which gets me -2 over 4, which is actually -1/2. Okay, so my axis of symmetry for this one is going to be right here. Okay, my graph is going by ones, so the -1/2 is to the left side of the y-axis, but in between that axis and the first line. Okay, so there's my axis of symmetry. Okay, so now I need to find my vertex. And we again just found that the x-coordinate is at -1/2. So I just need to find the y-coordinate. Okay, so I'm going to do that by plugging in a -1/2 into my original equation. So I have 2 times -1/2 squared plus 2 times the -1/2 plus 1. Okay, doing that math and solving that equation. Okay, -1/2 squared is a 1/4. A negative times a negative is a positive. Okay, plus 2 times a -1/2 is a -1 plus 1. Okay, and we should know that these two over here, a -1 and a +1, are going to cancel. So what I really am left with is 2 times 1/4, which is 1/2. 2 over 4, which is 1/2. Okay, so my vertex is at -1/2, 1/2. Okay, so on my graph, my -1/2 is already on that axis, and 1/2 is in between, again, right on that axis of symmetry, but in between, in the middle of that first box. Okay, so the next thing we plot is our y-intercept, which if we look back at our original equation, our y-intercept is 1, because that's my C term. So on my graph, I need to put a dot up here at 1. Okay, and when I reflect that, okay, remember I want to count how far I am from the axis of symmetry. Okay, so when I do that, I'm only over half of a square. So I need to go over that half of a square to the other side, and there's my dot. Okay, now this one, if you look, there is no other points between that y-intercept and my vertex. So I just need to pick any other point on my graph. And again, though, your best option is to always pick one that's really close to your known data. Okay, so I'm going to choose, because positives are easy to work with, I'm going to choose where x equals 1. Okay, that's my next positive number. I wanted that to be a highlighter. Okay, so that's my next line that's away from that axis. Okay, so if I plug in a 1 for x, I end up with 2 times 1 squared plus 2 times 1 plus 1, I believe was the original equation, okay, which gives me 2 times 1, because 1 times 1 is 1, plus 2 plus 1, which is really 2 plus 2 plus 1, which is 5. Give me that ordered pair of x equals 1 and y equals 5. So at 1, I need to put a dot up at 5. Okay, so here's over 1 and up 5. Okay, and then I again need to reflect that to the other side. So if I'm getting to that axis of symmetry, there's 1 whole box and a half. So I need to go over the other side. Here's the half, and here's the 1 whole. And there's my other point. So now I'm ready to make that parabola, that U shape, going through my points. Okay. So here's another one. Okay, and this one on here again, if we look at this, remember it does have an A term of -1. My B term is 4, and my C term is -1. That's always your first step on these ones that have that middle term. Okay, so I need to find my axis of symmetry, okay, which is that -b over 2a. So for this problem, I have -4 over 2 times -1, which is really -4 over -2, which is 2. So my axis of symmetry is right here on this dashed line where x is equal to 2. Okay, and remember that is also the first number, the first coordinate of my vertex. So I might know my vertex is 2 something, and to find that something, I'm going to plug in that 2 into my original equation. So I have negative. Again, that negative is outside, so it's going to stay there. 2 squared plus 4 times 2 minus 1. So when I solve that, I end up with -4 plus 8 minus 1. Okay, which gets me 4 minus 1, which is 3. So my vertex is at 2, 3. Move that dot onto there right away. So here's my axis of symmetry. My vertex is up at 3. Okay. So then the next step is always to find your first other point on your graph. So that's your y-intercept, which is your c term. So c equals -1. So on my y-axis, I have a point at -1, and then to reflect it, which is over 2 for my axis. So I need to go 2 the other way, and I get my reflected point. And now this one is again nice because I have a point in between that y-intercept and my axis. So I'm again going to choose this point right here where x equals 1. And I'm going to sub 1 into my equation. So I have -1 squared plus 4 times 1 minus 1, which gives me -1 plus 4 minus 1. Okay, which when I solve that, negative 1 plus 4 is 3, minus 1 is 2. So I have a point at x equals 1, and the y is 2. Point right here, which to reflect is 1 point from my axis, so I go 1 the other way. And there's my other dot. I can draw that smooth curve. And there is my parabola. Okay. Now I do have, and I'm going to do this one, but I think it would be a really good idea if you pause this video right now and you try this one on your own before you watch the rest to see if you're doing it correct. Okay, so please pause the video, try it on your own, and then come back, watch the video, and check your answers. Okay. So first step is to identify your A, B, and C. So A equals 4, B equals 8, and C equals 3. Second step, find that axis of symmetry by doing that negative B over 2A. And you don't have to write that formula down every time. I'm just doing it to help you remember it, which is really negative 8 over 2 times 4, which is really negative 8 over 8, which gets me negative 1. Okay, so my axis of symmetry, I'm going to draw that in red like I have one, is at negative 1. Making that dashed line there. Again, this is just to help me know where I can reflect my parabola. Okay, so the next step is to find that vertex. Okay, and I already know that the x is at negative 1 because it has to be on my axis of symmetry. So I'm going to plug in negative 1. So I have 4 times negative 1 squared plus 8 times negative 1 plus 3. Which when I solve that, I get 4 times 1 minus 8, or plus a negative 8, plus 3, which is really 4 minus 8 plus 3. 4 minus 8 is negative 4, plus 3 is a negative 1. So my vertex is at negative 1, negative 1. And I'm ready to plot that point. Okay, and if I look at this graph, you should notice it's going by 3s, okay, on my y-axis. So negative 1 is actually right under that line. It's not halfway. No, might start looking there on my little graph, okay? But there's my negative 1, negative 1. Okay, next point is again your y-intercept, which is always your C term, which in our case was 3. So my y-axis, I need a dot at 3, and then I reflect that, and that's 1 hop from my line. So I go 1 hop the other way, and I have my next point. Okay, and now this one again, you didn't have a point in between. Okay, so I need to pick the next best number, which again for this case, if you can choose a positive, so my next positive number is 1. So I'm going to plug in x equals 1 for my equation. Okay, which when I plug that in is 4 times 1 squared plus 8 times 1 plus 3. And when I evaluate that, it gives me 4 times 1, because 1 times 1, plus 8 plus 3, which is 4 plus 8 plus 3, which gets you 15. So I have that ordered pair, x, and this is really my y, of 1, 15. Okay, so up here on my graph, I'm going to go to 1, and I do have all the way up to 15. And to find my last point, that 5th point, that 15 is 2 boxes away from my axis of symmetry. So I go 2 that other direction. And there is my 5th point. Make that smooth curve, just like when we did linear functions. and exponential functions, okay, you want to make sure you put a line with arrows connecting your points, okay? And that's graphing a quadratic with that b term, that middle term. Find your axis of symmetry, use that to find the y-coordinate for your vertex, graph your y-intercept, and find one other point.